viewers, we are once again welcome to my YouTube channel, Rediscover Your Touch. We are actually tackling other examples concerning our rates that we discussed previously. And this time around, we'll be looking at different perspectives of our rates in aspects to finding either the time or the distance as well. And before we commence, I'll actually urge my viewers out there to find some time to subscribe to my YouTube channel and like and share my video as well to other colleagues who might be in need of this knowledge. So without wasting my time, we'll sail to the examples and then we'll actually bring out the data from the examples and then we'll work out on them. Okay, so kudos. Um, the example for lesson 5 today, we have a train traveling at 105 km per hour goes through a tunnel 1,575 meters long. So we are being asked here to calculate in seconds the time a passenger on the train spends in the tunnel. So we are actually looking out for the time in seconds within which a passenger on the train actually spends in the tunnel. So without wasting my time, I'll bring out the data and then we set sail and work on the data. Okay. So per our example, we had our average speed to be 105 kilometer per hour, and we have our distance to be 1,575 meters long, but our time hasn't been stipulated, but rather the question demands that we find our answer with respect to time in seconds, and that is exactly what we'll be tackling on this lesson. All right, so per our solution, we are being asked to find our time, and we actually have our average speed in kilometer per hour, but we have our distance to be in meters. That alone tells the distinctive features between those two quantities, and for that matter, we'll be tasked with manipulating the standard conversions in order to attain the same unit. All right, so we have 1 kilometer is equal to 1,000 meters. So if we have 1,575 meters, that gives us x that we do not know. So as usual, I trust by now you are used to this technique. So we have 1,575 times 1, which translates to give us 1,000x. So we divide both sides by 1,000. And 3 zeros cancel 3 zeros. And over here, we could choose to maintain it as a fraction, or we could better still, by the law of conversion of fraction to decimals, we are going to round our decimal point to the left hand side by the number of tens or zeros we are having here. So we are going to have x is equal to 1.575 kilometers. That is moving thrice, 1, 2, and 3. It translates to give us 1.575 kilometers. So I trust we are good to go now. Per our definition or our formula for time, we are going to have time is equal to distance over average speed. And I trust by now you are used to this acronym AS, which stands for average speed. All right, so we substitute the values and we have our distance is 1.575 all over 105. 5 all over 105. So we actually use the long division technique just as the data has been depicted in order to get or arrive at our answer. So we have 105 being the divisor, and then 1.575 becoming our dividend. So we ask ourselves, how many times would 105 go into 1? 105 typically is greater than 1. So it translates to 0 times. And then we introduce our decimal point. We add the next number to 1, making 15. 15 is still smaller as compared to 105. So we still have 0. And then finally, we have 105 going into 157. And that is what? Ones. So we have 105 goes into 157 ones. And 105 times 1 gives us 105. So here we subtract. So 7 minus 5 gives us 2, and then we have 52. Okay, 52 being our remainder here is smaller than 105. So we move on to add the next number. So that is 5. And the usual instances, we are going to find out the factor with which 105 factorize 525, or how many times 105 will actually go into 525, which is 5, and gives us the same amount. So 5 to 5, and it leaves us without a remainder. So in that sense, our time is 0.015 hours. 0.015 hours. That is kilometers cancels kilometers, and then we have hours standing alone. So by the demand of our time, we are supposed to leave our answer in seconds. And for that matter, we ought to change the unit of our time. So we are still again going to manipulate our conversions, this time around time. So we have into seconds, 1 hour translates to give us 3,600 seconds. 1 hour translates to give us 3,600 seconds. So if I have 0.015 hours, it gives me X, which I do not, or we do not know. So as usual, our technique, we are going to have our cross multiplication, and then we have 1 times X, which is X. And then we further move on to have 3,600 times 0.015. 3,600 times 0.015. Over here, we could translate the decimal into fraction in order to make our workout more visible. So we are going to have 3,600 times 15 over 1,000. So we have 2 zeros cancels 2 zeros, and then 5 goes into 15 3 times, and it goes into 10 twice. So rewriting our remaining values, we are going to have our time is equal to 36 times 3 over 2. And 2 goes into itself once, and 36 18 times. So we are going to have 18 times 3. 18 times 3. Multiplying 18 by 3 gives us 54 seconds. So therefore, our time translates to give us 54 seconds. So I'll actually do a wrap up on our today's lesson as to what we've really tackled thus far. So we have a question whereby our average speed has been provided, Our distance has also been provided in meters, and we were tasked with finding the time in seconds. And for that matter, we really ought to do some manipulations on our standard conversions in order to attain our answer. So from the beginning, we ought to change our meters into kilometers, and translating 1,575 meters into kilometers gives us what? 1.575 kilometers. And moving on, we substitute the values into our formula for time, and we equate everything to give us what? 0.015 hours. 0.015 hour. And for the demand of the question, we really ought to translate our answer into seconds. So that means our value for hours is really not acceptable. So in that sense, we really have to manipulate our standard conversions one step more in order to arrive at our desired answer. So using that technique, we are actually going to translate from hours into seconds, and then we actually arrive at our time being in seconds. And that really is how we really need to go about a typical question like this under rates. So, like I always used to say, I'll urge each and every one of you there to subscribe to my YouTube channel, to like this video, and also share among your colleagues to help them alleviate the pressures that sometimes rate brings to students. And in the latter, we will all end up helping one another. Kudos to you all, and get in touch with me on my next video on lesson 6 concerning rates. Bye.